Most of you are familiar with this number system. It starts with rational. It starts with first of all real number. Okay, real number. Then a rational number, rational number, irrational number. Then it goes on. Let's start from starting. First, first is what? Wall. Not wall. Natural. Natural number. Natural numbers. Look, natural numbers would be those numbers who which starts uh, from 1, not from 0. Okay, from 1. Remember, from 1, if a number is starting from 1, like that, it goes to the infinity. So this will be known as natural numbers. Clear? So natural number will start from 1, then it will keep going on till the infinite. Next, whole number. Okay, whole numbers. Now it's all about where does number start. It's all about where does number start. As we saw about natural numbers, natural number is starting from 1. In this case, one number will start from 0. Okay, and it will keep going on till the end, till the infinite. Towards there is infinity numbers. Okay, even we can't imagine. So remember, what is the difference between them? What is the difference between them? It is starting from 1, whereas this number is starting from 0. So this is a huge difference. So it will start from 0. Clear? Now next which comes integers. What would you like to say about it? Do you have any information regarding it? Can you explain? It is nothing but look. It has what? 2 types of natural numbers. First this, and second negative natural numbers. First positive. This is what? This is a positive natural numbers. And second which is negative natural numbers. And it will have what? A whole number. Clear? For example, this is a hint of showing infinity. 3, 2, hold on. -4, -3, -2, -1, 0, 1, 2, 3, 4, till the infinity. Now here, from here till the infinity is natural number, but here addition is hidden. With this addition are hidden. Additions are hidden. Whereas here subtract or from here till the end is infinity. This is that. But here what's the difference between this and this? All this is with addition, and all this is with subtract. Okay. And this is what? This is whole number. This is natural number. So number which can be minus, negative, 3, 0, any. Okay. Number can be with addition, can be with subtraction. Number can be 0 in the definition of integers number. Next, I think rational number. It is a very popular. This is very popular among this. Rational, it is nothing but a number. We are understanding types of numbers, you can say. Otherwise, names of numbers. We are understanding. So here this is a number. This was also a number. This was also a number. This was also a number. But name of this number is what? Natural. And name of this number is what? Whole. And name of this type of number is what? Integer. But rational number will look how? A rational number will look how? It looks a number will be a number, and there would be two number. One is upper, a second is down, but together will be seen as a unit, as a number. Okay. For example, 4 by 5, 4 by 5. Here 4 is upper number, 5 is a downward. So yeah, this is a rational number. Now let's understand it by definition. Definition of it says any number, if any number, whatever you are taking, any number you can take, but that number should be in the form of P upon Q, where P is integers, Q is also integers. Okay, integer. When it comes to integer, then you need to make sure that upward here can be what, -4 or -67. Yeah, same here, -20. Okay, when it comes to integers, and it is true that here this numerator can be negative numbers, can be positive numbers, can be both. But here denominator should not be 0. Denominator should not be 0. If denominator is 0, then yeah, it will run. But denominator number should not be 0. Okay. In the case of rational number, for example, 4 upon 0, this will not define rational number. This will not define a rational number. Okay, clear? What else? So this upward is known as a denominator, and this downward is known as a denominator. Clear? Denominator upon denominator. Next, irrational number. Any number that cannot be presented, any number, whatever you are taking, if that number cannot be represented in the form of P upon Q, then that number will come in the category of irrational number. Any number. For example, let's start from 2. This 2 cannot be represented root 2 upon 1. No. Okay, that's fine. But there should not be a number, should not be perfect number. For example, root 4. So it will become a 2. It will become root 2 because value for root is 1 by 2. Value of this root is half, already now. So 2 and 2. Value of this is 1 by 2 and 2. 2 will get cancelled out. This 2 will, then in the last step will be 1 and 2. So 2 here you can see. So here 2 is what? 2 is a rational number. 2 is a rational number. 2 is an integer. 2 is a natural number. 2 is a whole number. Clear? So root 4 will not be a rational number. Root 4 will not be a rational number. Yeah, root 3 is a rational number because 3 is not a perfect square. This 3 is not a perfect square. Okay. So next can be root 5. Next can be root 5. Look at this. Next which comes real number. Real number, okay. Real number, all these are real numbers. All these are real numbers. Okay, real numbers are all these. So here it will categorize this 2 into different. This will be in another part, this will be in another part. This will go like this, this will go like this. But irrational is in another. This is the second part This is the second type of real number, and this is the first part of real number. I am trying to say that this is a real number. Then it will be categorized. It will be classified into two parts. First, which will come rational number, and second, irrational number. Okay, like that I was trying to say. Now, next. Next, there are some questions based on it. First, let's start. Let's understand about rational number. About rational number. Now, whatever I ask you, tell me, three rational number between 2 and 3. 2 and 3. This is a question. Tell me, tell three rational number between 2 and 3. You would be thinking it is impossible. Where are three rational numbers between? There are nothing. There are nothing numbers between 2 and 3. You are saying this. But it's not true. There are a lot of rational numbers between two integers, between two rational numbers. Okay, there are a lot of rational numbers. Even I can say that there are infinity rational numbers between any two rational number, between any two integers. There are infinity rational numbers between two numbers. Okay, I am going to prove that there are three rational numbers between them. If it can be written as 2 upon 1, we didn't change our number, and 3 upon 1. Okay, now it is clearly rational number. We want how much three rational numbers? Three rational numbers we want. You can multiply whatever, but whatever you are multiplying number, so you multiply in both the sides, in numerator also, in denominator. Then question will be same, will remain same. Similar here. Okay. Now simplify it, and then 6. Now we have how much? 12, then 13, 14, 15, 16, 17. Now you can see 1, 2, 3, 4, 5. We got 5 rational numbers between 2 and 3, like that. Even you can multiply this with 10 numbers, whatever you want. So according to question, first let's look at the questions. What is the question saying? Okay, we wanted how much? 3. So you can write 3. You can write 3 whatever you want from this. So like that. That's how numbers are found. Rational numbers are found between any two rational numbers. Clear? Have a look. Now I have question. Read this question and give me answer. Read this question. It is saying every integer is a rational number. Now it is saying every integer. Yeah, it's a true. You take any number, okay? You take any number, but should be integer. For example, -5. This is integer. 77. This is integer. Now we have just taken some integers to define that, to say that, yeah, is it our statement is correct or not? Okay. So it can be written, yeah, one is hidden in form of a denominator. Here it can also be written. So it is a truth that every integer is a rational number. Yeah, final answer would be yes, true. But every rational number, what if the answer says question is something else? Question says that there question says every rational number is a integer number. Now tell me, is statement correct? Is this statement correct? This, I would say no. This is correct. Okay, this is correct. Even we saw, or is it correct? Now any number you can put. 5, it is rational because 1 is hidden in denominator. It is a rational. Now it can be said that this is integer. But what if I am taking this? This is a rational number. But we can't say that this is an integer. No, we can't say. Because this is a rational. This is rational. Integers are simple. 6 minus 6, 77. Yeah. Even we saw definition of each numbers. This is not integers. Rather, it is a rational. So every rational would not be integer. False. Okay, clear? No. Find the 5 rational numbers. Find 5 rational numbers between 1 and 2. How would you solve it? How would you find 5 rational numbers between two integers, between 2 rational? So we have this. How much? 5. Even we can multiply this by 20. Even you can multiply given number with any number. Okay, this will become how much? 20 upon 20, isn't it? Now next 2, it can be written as, so we are multiplying with 20, 40 upon 20. Now, how much? We have even 80. We have how much? 20. 18 numbers between 1 and 2. So here 21 upon 2. Okay. So we have written 5. We have written 5 rational numbers between this number. So these are 5 rational numbers. Now tell me, next question is every natural number is a whole number. Tell me, how can you say that every natural number would be whole number? How can you define? Look, natural number. Let's see. 1, 2, 3, 4. These are natural numbers. Now, whole number. Yeah. But we can say every natural number. This is true. All this come in whole number. But every whole number would not be what? Natural number. Okay, natural number. For example, 0 would not be natural number, but 1 would be. One whole number is a natural number. One whole number is a natural number. Clear? What if I ask you? Tell me, 10 is vowel. 10 is a vowel, and I am 10 is a vowel. Now tell me, 10 if 10 is a vowel, so it will be natural? Yeah. Only vowel is what? Vowel starts from 0. Just have a look. Now next question. Every integer is a whole number. Is it correct or not? This statement is correct or not? Look, every integer, let's say 5, 6, even 0 is what? Is it a whole number? No, false. Because -5 is not a whole. -5 is not whole. Yeah, 6 is a whole number, 0 is a whole number. Clear? But what about the -5? -5 is not. Okay? -67. So positive natural numbers are not whole numbers. Yeah? That's why this statement is incorrect. Now what if every whole number is an integer number? Is this statement correct? If yes, then tell me how. Every whole 0, 1, 2, 3, 4 is what? Integer. Yes. All this come in integer. but all these don't come in whole number. But here, all these are coming in integer category. In integer category. In category of integer number. Just have a look. Now next. This is question. From here we will understand something else. First, now 3 3 is 9, 1 0 again, 9. This will keep going on. This will keep going on. But there will not be never end. So here 3 is a repeating number. After applying decimal, 3 is a repeating number. Okay. 3 is a repeating number. If there, so hold on. This was right. Second is 0 on. There is a head in this case. Now here 0.1. Now here, from this we are observing that here only 3 is a repeating. Only 3 is a repeating again and again. Now here 10/3 is what? Rational number. But if there is no repeating after decimal of rational number, if there is no repeating and there is no end, numbers are not repeating after decimal and there is no end, will be considered as irrational number. but except that whatever is happening will be considered as rational. Now you can see here 10 upon 3. Is 10 upon 3 rational or irrational? I would say rational. How? Let's see. Here 3 is repeating. 3 is repeating after decimal. 3 is repeating. Now one point more. Is reminder end or not? If reminder not end, here you can see reminder is keep going on. Reminder is keep going on. So here reminder is keep going on. Reminder, there is no end in a reminder. Whereas here after decimal number is not, there is no end. But here this is repeating. This is repeating number. This is there is no end in reminder and in decimal. There is no end. That's why it will be considered as rational. Rational. But here you can see. Here there is an end. There is an end. And here after decimal is also end. So it will be considered as rational. Rational. Okay. Why? Irrational. Now any number, any rational number will be considered as irrational number when there is no end. There is no end. But there should not be repeating number after decimal. There should not be repeating number after decimal. Then that rational number will be considered as irrational. Okay. So here from here we are observing that some rational numbers would be irrational number. Some rational number would be irrational number. When there is a no repeating, when there is a no repeating in rational number. If there is a no repeating after decimal, there is no repeating number. Okay, and yeah, that's it. And there is no end. There is a if a rational number is not terminating, if a rational number is not repeating, then that rational will be considered as irrational. Clear? Here in this, here you can see. Here is end. Here is also end. It will be considered as rational, but it will not be considered as irrational because irrational says that there will not be end after decimal, as well as there will be numbers will keep going on till the end. Numbers after decimal will keep going on. So that rational will be considered as irrational. Now, what else here? Here you can see these are groups. This is a group, and this group numbers are repeating again. This group, but here in this only one number was repeating, but here group number is repeating. Group number is repeating, and when it comes to repeating, then you need to make sure that there is no end. There is no end in a remainder. So it will be considered as a rational, not irrational, because this 7 upon 10 is 1 upon 7. 1 upon 7 is what? Repeating. It's non-terminating. Okay, we agree. It's not terminating, but it's repeating. And irrational says that there will not be repeating number. Rather, there will be different number after decimal will keep going on. There would not be end in the case of irrational. So here one point is which you need to understand is that, and we have understood just right now, is that some rational number could be irrational number when it comes to repeating, terminating, non-terminating. Then we will be able to consider that rational number as a irrational number when it will come to repeating, terminating, and non-terminating. Just have a look. Yeah, look. What have been our real number is considered into real number is classified into a rational number, irrational. Now look at this. Any rational number will be considered as a rational number when there is no non-terminating, which means terminating, not terminating. I am saying not terminating. Yeah, not terminating, which means there is a no end. Meaning of non-terminating is there is a no end. Non-repeating, non-repeating. Clear? Terminating, which means that there is an end. Yeah, rational number will be, it can be repeating, and terminating. Sometimes you will realize that there is no end. For example, non-terminating. Okay, non-terminating. But this will be repeating. This will be repeating. Yes. You can see differences between them. Have a look. I have some questions based on this. Now we are going to take up some questions based on irrational. Based on irrational. For example, so 0.333 and it is not terminating. A, B, Q. Okay, this is question. This is question. We have to write this given in the form of P upon Q. Okay, P upon Q. So let's see how to solve it. 0. First of all, if you not you can take it x is equal to, just apply a variable 0.3. Here you can see 3 is repeating, 3 is repeating, so 3 is bar. Okay, now next, just multiple 10 in both sides, because here one number is repeating, one number. If there are two numbers repeating, then there would be what, 100. So here one number is repeating, so here you will multiply 10 number in both sides. This is one equation. Remember, we have applied a bar. Okay, it is indicating, it is showing that 3 is repeating. There is no end, but it is repeating. Now this is not terminating, this is repeating, so it is what, rational. So here 10x and 10, so it will become 0.33. 3.30. Now this is equation to, this will become 1 minus 1 second of 9x seven, and this 2.7. Is that correct? No, this is incorrect. Here 0.3 multiple 10, 3 0 0 0 3 3 0. So it will be 3 0 0 it will be 3, and then it will become 1 by 3. So we have found it in this form. This is what, in P upon Q form, 1 upon 3. This is question. This is question. Look, we have to convert it into P upon Q. How? Just write it. Okay. Now these two numbers are repeating. These two numbers are repeating. So you have to multiply 100 in both sides because two numbers are repeating. So 100x and now 1.27 it will be multiplied by 0 0 0 0 0 0 1 0 0 7. So 1 2 7 1 2 7. No. 1 2 7. Now 1 to 7 we are going to subtract 1 2 7 2. Okay. Here how much? 5. Again 5. 0. So here 0, it will put 8. But hold on, it is incorrect. Three, 7, 6, 1. From 1 and 2, 126. Is it correct? Here 0 0 and then 6 126. It is this is correct. Yeah. So it will be 126 upon 99. This is the answer. Even you can simplify it. 3 3 is a 9, 3 3 is a 9. 3 4 is a 3 2 is a 4 2 6. 3 1 is a 1, 3 1 is a 1. 14. So 14 upon 11. It will become 14 upon 11. This is the answer. Okay. So it can be written in this form. This is final 14 upon 11. Next question. Find find an irrational number between. It is very easy. It is very easy. So we were finding some rational numbers between given two rational numbers. Now it's a time to find some irrational number between given two rational numbers. So here 1/7. It can be classified. It can be simplified. No. Zero point 142 857 like that. Seven two 0.720 6 8 4 25 5 4 again 7 10 1 0 again 1 then it will okay like that 0.285714. Now you can find infinity irrational numbers between them. How much? Find an irrational number. So 0 1 1 5 2 8. This one 0 1 1 6 2 8 5 7. Even 1 2 next 3 2 8 5 7. Okay, this 3 0 1 7 2 8 5 7. Okay, like that you can find infinity irrational numbers between given two irrational numbers. Just have a look. Next question. Next, which is you have to tell is a given number rational or irrational? You have to tell. After understanding this, root 23, okay, and root 225. Now, which one is rational and which one is not rational? Which one is irrational? So here, if number is a perfect square, then that root number will be considered as rational. Okay. For example, here this 23 is not a perfect what a square. That's why it is irrational number because of this 23 is not a perfect square. Now in this case 225 is a perfect square. That's why this type of numbers are considered as rational, because after simplifying it will be what, 25, I think. So this is a perfect square. What is that number that will be multiplied one more time will give a perfect square? For example, 25. Let's take 25, and we are going to multiply 2 times it. So 5 5s are 25, 2 5 2s are 10, 12, then 5 2s are 10, again 2 2s are 4, 5, 5 2 6, what? Then 25 is not there. Let's take 15. 5 5s are 7, 1 5, 5 2 2. Yeah, 15 is the perfect square of 20. So it will be classified like that, 15 square. Okay, what can be written as? This can be written as root 15 square. So as you know, value of root is 1 by 2. So 2 1 by 2. After cutting it will be 15. So 15 is a perfect square of 225. So 15 is integer. 15 is what, a rational number. So it is what, rational. And this was irrational. 23 is irrational. Clear? Now something else based on this. Something else. Something else. For example, this add 2 plus 5 root 3 and root 2 plus root 3. Now we are going to simplify it. Now it is the same that add this both. 2 plus 5 root 3, and we are going to adding root 2 minus 3 root 3. Now here you can even take a common, this. Look number in root. So here 2 and this 2, then this 5 root 3. Oh my god. Now this is common. Now 2, this is a 2 and there is a 1. 1 is hidden. So it will be how much? Yes. So 3 and 2. Again 5 minus 3. It will become 2. 3. Okay, that's it. It cannot be classified further. That's why here is answer. Is a final answer. Now we have taken common root. Then we just subtracted and add. We have added that. That's it. That's how root with our operations are solved. That's it. Now next, what about multiplication within a rational? multiply 6 root 5 by 2 root 5. So it is the same 6 root 5 multiplied 2 root 5. So under number is common. So 6 to 5 5s are 20. 225. 5 5s are 25. Now this is a perfect square and a square root will get cancelled out. 12 5s are how much? 60. So 60 is a final answer. Now next division. Division. Just you write it in mathematical way. Okay, like that. Now here it will cut it by root 5. Isn't it? 2 4s are 8. 4 root 5 is final answer. Is a final answer. Otherwise you can see here. Okay, like that. So 3 5s are 15. Which one is the correct? So this is incorrect and